Hey guys, welcome back to the Basement Workshop. Was just out of town for a long weekend, anxious to get back to this electrostatic TV. But a package just arrived from Amazon during the latest Amazon Prime sale event. I ordered up a device, and there's an FNIRSI multifunction multimeter oscilloscope. Now, why would I order this when I've got all this high-end, obsolete, overkill stuff in the background, scopes and RF generators, and I've got my trusty vintage Fluke multimeter. Well, I got it because I often get asked for recommendations on a basic budget, modern, currently produced gadget that can be used with tube-based equipment, and I don't have anything to recommend. I've seen other folks play around with stuff like this, so I'll point them to a video like that. But I thought, hey, maybe it was my time to jump in and pick one up. So I got this for all of, I think, 61 or 62 bucks. And I wanted to get a basic model. There are higher end models for a few more bucks that can do more. So this is just a basic single channel scope. I think for $5 more I could have gotten the 2-channel. But honestly, for the type of stuff that I do, I rarely do, so I want to get the cheapest one I could. And let's see what it can do. So it's a single channel, 10 megahertz oscilloscope. It's a multifunction, a multimeter. And it's a signal generator, but I've come to find out from a comment from an online friend that it's really limited. I think it only goes up to 50 kilohertz, and it might be fixed output level, or maybe you can select 2 output levels. I think it's more for feeding back into itself to display on the scope than it is to inject the signal into a device under test. So I think mainly we're going to focus on the oscilloscope and the multimeter, and I want to try using it in conjunction with this project, which is an electrostatic TV that has at the highest potential close to 6,000 volts, and we've got some sawtooth waveforms that are upwards of 300 volts in amplitude. Now, if I was to just use this stock, I would very quickly damage the meter. It certainly can't handle 6,000 volts. Well, let's see what it can do. Allegedly, multimeter, DC voltage up to 1,000 volts. AC voltage up to 750, DC current 10 amps, AC current 10 amps, frequency up to 10 megahertz, so it has a frequency counter built in. It has a temperature probe, minus 67 to 2372 Fahrenheit. Okay, I'm not sure what kind of probe you get with that, it won't melt. Resistance up to 20 meg. And down to 200 ohms, is that right? Nah, it's got to be lower than that. We'll try it out. And capacitance meter up to, looks like 1,000 microfarads, down to 10 nanofarads, basically. I bet it can go lower than that. I'm taking all these with a huge grain of salt. One, even though the meter electrically need to handle 1,000 volts, I don't think I'm going to trust the cheesy probe that comes with it with 1,000 volts on it. But let's continue. That's the multimeter parameters with the oscilloscope here. Bandwidth 10 megahertz, but it's only 48 megasamples per second, meaning if you feed a 10 megahertz signal in, it's doing less than 5 samples per second. If it's a repetitive, like a 10 megahertz sine wave, it'll probably dither it a little bit, so it'll build up and get a decent looking sine wave. But if it was a random spurious signal, you're just going to kind of have some random dots. But the thing is, if you're working with TVs and AM radios, you really don't need to get into the megahertz. TV horizontal is 15.75 kilohertz, vertical 60 hertz. I was looking at specs on oscilloscopes that were available back in the 50s, and most shops didn't have one at all, but I looked at a basic RCA service bench type scope, ICO, and similar. They had bandwidths of like a megahertz, maybe 5 megahertz. Very limited options with the sweep range or the vertical sensitivity. you're really looking for, does the waveform basically look like they show you in the service info? Is the peak-to-peak amplitude within the ballpark of what they're showing? You're not trying to get 1% or better accurate measurements, but supposedly this can do it, so we'll see. Input impedance 1 mega ohm, AC/DC. They include a ×10 probe, but rarely would you use a ×1 probe with any scope. You use a ×10 probe to get 10 megahertz input impedance and higher voltage. So if you were to use a 1-to-1 probe, 40 volts max input, DC, 80 volt peak to peak. But with a ×10 probe, supposedly 800 volts peak to peak, plus 400 volts DC. Maybe. What I plan on doing with this, assuming my BNC connector will fit onto this properly, is I have a ×100 probe. And you can get those pretty inexpensively on Amazon, eBay. And that will divide the input by 100 rather than by 10, which should be plenty to let us probe around safely inside of this. And one nice thing about using handheld devices like this that run off a battery is this is a cold chassis, but a lot of these sets we work on, radios, TVs, they're series strung, hot chassis. Technically, you don't need an isolation transformer if you're using one of these. Still a good idea so you don't shock yourself, but you won't damage this because it's plastic and it's running off of batteries. It's not connected to the earth ground, so just something to consider. Vertical sensitivity, 10 volt per division to 10 volt per division, vertical displacement, horizontal time range, yada yada. A basic scope. So let's pop this open and see what comes with it. My biggest concern about using this as a scope is it's mainly got the controls you'd see on a multimeter, which is a big rotary switch in the middle to select different modes. How to use a scope. Used to scopes having a bunch of knobs for vertical volts per division, horizontal time base, trigger modes, and AC/DC coupling and all that. You don't get any of that with this. So I know there's some on-screen menus, but there's also an auto button. I'm hoping that it can auto-choose the right voltage and time base range for looking at typical waveforms, so we don't have to hunt and peck through a menu. All right, here's what we get. So we got BNCs on the top. That's what I meant about. I'm hoping I can use some, like I have a Tektronix ×100 probe. With this recessed plastic, I'm not sure it's going to fit in there, but we'll give it a try. So DDS, that is your direct digital synthesis waveform output. It can do sine, square, triangle, up to 50 kilohertz. And then DSO, that's your digital oscilloscope. These connectors look a little, looks like the inner part is gold plated, the outer nickel plated brass. Maybe, probably not. Ideally that's what they would be, I think. Or silver plated. So we got a power switch on the side. We can plug our charger in here. I assume it's USB-C. Yeah, looks like it. Build quality, it's a little flimsy. So here's my Fluke 27 military version. I mean, this I could drop off a 2-story building, it'd probably be fine. This I would worry about dropping it off my workbench. Rotary switch, it's okay. These, I thought they'd be a little bit mushy rubber, but no, they're kind of hard plastic, clicky things. But at least you get decent tactile feedback. So what it goes all in here? Oh, it's just a kickstand. Okay, there's nothing accessible back there. All right. So does this have a charge in it? As shipped? Oh, yes it does. I was about to say no, it does not. Okay. Yeah, we want English. Please, how do I select English? So we get some beep feedback. So we got up-down arrows, we got left-right arrows. I guess enter selects. Yes, it does. Multimeter settings. Let's go right to the scope. So left, right buttons select the mode, and enter chooses it. So there is our oscilloscope. Alright, so that's the device itself. There is an accessory kit with it. Let's see what we got. I mean, I'm ripping on it a little bit, but for 60 bucks, I mean, I wasn't expecting it to be mil spec or anything. I mean, if this thing basically works and displays some useful info, I'm fine with that. And I don't have none of these Fluke 27s, they can't measure frequency, they can't measure capacitance. And yeah, I got a separate capacitance bridge, but it's too based, it's old to haul that out, and it's kind of a pain. I do have one of those little cheapo LCR meters that are so popular. But if this can measure capacitance and it's a decent multimeter, yeah, that's a win. So this would be for your signal output. So BNC into this device, and you can get your waveform out. I would imagine if you go into DDS mode and select, say, a 10 kilohertz sine wave, then you switch to the scope mode, it's going to continue to put that out of this, even though you switch to a different mode. In which case we should be able to view it on the scope, you know, view the signal that's coming out of it on the device itself. So these are the multimeter probes. Yeah, they're a little... I guess they're gold wash, or maybe that's brass plated, hard to say. Not crazy sharp, a little long, I wouldn't push too hard on them, but okay. So they're good for 1,000 volts, 20 amps, maybe. So we got protective caps on the end. Again, I wasn't expecting much in the way of probes, and there are so many inexpensive probes that you can get out there online that, you know, we could always upgrade those. I'm not that concerned about it. So it's that, and there should be a scope probe in here too. Oh, here we go. Alright. And here's a user manual, which, well, we'll take a look at it. I don't expect it to be spectacular. So it's a different colored snap-on rings, so if you have multiple probes, you can tell one from the other. So we've got a clip-on ground. Just goes on there. Get the usual hook thing. Yeah, it doesn't feel great. I'm guessing there's probably not a whole lot of great shielding on it. 100 megahertz times 10, 6100. I think that's what a Tektronix 6100 series probe, which is this. This is not. That should be a compensating capacitor. Yeah, it looks like with a small cross plastic tool you could get in there and adjust that trimmer cap if you needed to. Alright, so that's that. So just like this, I should put my finger on it. I should... Yeah, I'm seeing a little bit of noise. So what I don't know is when you're in scope mode... Oh, okay, so that's just... so this will put you into different modes automatically. So this should be resistance mode. Okay, the multicolored display is kind of nice, I gotta admit. It's a pretty good size here. So let's start with the multimeter and do some basic stuff. Let's just... Got some capacitors and resistors floating around here on the workbench. Let's see if we can measure them accurately. So let's get these shrouds off. So OL, overloaded, means infinite resistance. This should go to 0.4 ohms. I don't know if you can zero this out or not, but okay. Oh, here's some vintagey ones I just removed. So this should be allegedly a 1 meg resistor originally. What are we at now? 1.14, and then mega ohm. It's a little hard to read down here in sort of a stylized script. So here's a new one. It should be 2.2 meg. 2.18. It should be 1 meg. And these are, I think, 10% resistors, so 0.99. I mean, yeah, that works. Let's try measuring a capacitor. This is 0.01 microfarad or 10 nanofarad. 9.89 nanofarad. This guy here, this is 33 nanofarads, 1.033 microfarad, 33 nanofarads. So I don't know if you can change that for those of us in the US. We don't typically use nanofarads, not in this hobby anyways. And even though this is a German-made cap, I believe VEMA, it is marked as 0.033. So it'd be nice if you could see 0.033 on the display rather than having to do the mental math of shifting over the decimal point. But it says 0.033 in the cap, but it says 33 on the meter. But yeah, that's the same thing if you adjust for the units. So yeah, that seems to work fine. Scope, touch this, goes to whatever function's on here. Push mode, and you're back in scope. Alright, so maybe by default it's putting out something on these already, so let's try hooking up the scope right to these guys. Alligator clips are a little, shroud slides off real easily and it's kind of slick. Scope ground, super stiff to try to open up. One slippery and one stiff. It's a little hard to get together. There we go. And hey, it is automatically putting something out, even though I didn't go into this mode yet. So that's cool. So if I put in auto mode, so it does, but man, that's slow. So it looks like when you click auto, it automatically goes to the highest gain, so it's shooting right off the top, and then it slowly comes down. I would think you'd go the opposite way and go to the highest volts per division and start increasing it, but that's just me. Yeah, so there's 1 kilohertz sine wave, 3 volts peak to peak. Let's see if we can get into the mode. Oh, interesting. When I clicked mode this time, when I'm in the scope mode, I went to the function generator. Is this touch screen? No, it's not. So you gotta use, I'm guessing, up down arrows. Yep. Let's do, that's not a sawtooth, that's a triangle. Alright. Then you do step, logarithmic, or curved, random audio signal, sync pulse, a Lorentz wave, and that's that. And every time you push something, it beeps. That is not a sawtooth wave. So what about amplitude? And what about frequency? I wonder if it's just fixed at 1 kilohertz? Well, put it this way, if you can dial in the frequency, it's not going to be much fun because there's no numeric keypad on here, so you have to do up-down arrows, say in 1 hertz increments, or do 1 digit up-down, move to left-right to another digit up-down. It's not going to be fun to enter a frequency. So I'm thinking the main function or feature, or reason to use that is just so you can display this on the scope. But hey, there it is. There's a scope. It's doing something. All right, let's stop messing around here and do a better one-to-one comparison. Fired up a WaveTech 183 function generator, put it in sawtooth mode, and I'm feeding that into my Tektronix 2465 scope. And this guy. I put the scope in cursors mode. I eyeballed it best I could to get the cursors right on that. You see, that's one problem with these analog scopes. Even though it has a digital readout, you still have to position these 2 lines with the help of these knobs and get it right on there. The negative peak of the waveform as best you can. Whereas the digital scope It's basically a frequency counter, which eliminates this, eyeballing. But this with my cursor set says 23 kilohertz. Well, let's see what this guy says. 22.64. So which is more accurate? I'm actually inclined to trust this more because I haven't calibrated that. I bought it used, and again about having to kind of eyeball it. But that's pretty close. That's pretty close. Now, something I want to point out about this guy is somebody had noticed I had it in ×1 mode, and I didn't realize there's a switch on the side of the probe. I posted a photo of this on my Patreon, and somebody mentioned that. Now, I switched it to ×10, so I'll go back to ×1. The waveform gets huge and goes off the screen. Go back to ×10, and it's small, but this always says X1. I don't know if that means something else or if that's supposed to indicate the state of the probe, but if it's supposed to be the state of the probe, and it's not working at all. Anyways, you should always use ×10 mode because it increases the input impedance sensitivity of the device, and also how much voltage you can put into it. So it says it's about 1.94 volts. Let's see what the Tektronix has to say. I'll put that in Delta V mode and do the same thing about there and about there and about 2 volts. So they're within, I don't know, I'm not going to do the math, but they're within a few percent of each other. So for the kind of work I'm doing, that's plenty accurate. Now, the other thing I want to still try to resolve here is what is going on with when I change the time base. The waveform is getting all weird. So let's start when I go to lower time bases. Let's go down 1. And notice it starts rising and falling. I was just chatting with a friend on Patreon who has a similar model, maybe the same model, and he noticed that too. And he was thinking it's some type of aliasing with the sample rate. It's kind of looking like it's modulated the noise on there, and there really isn't. And the lower I go with the sampling, the more pronounced it is. And now, oh wow, yeah, no, that gets absolutely horrible. And now, did this wrap around? No, I'm still going down. Then the amplitude craps out, and it just does all kinds of. This is all complete nonsense. However, the reality is I'm looking at a there's no reason for me to go that low because I'm looking at a much higher frequency. What I really want to know is if I put a much lower frequency in, is it fine? In other words, is there something wrong with this, or is it just trying to look at a high frequency signal at a very low sampling rate? And that looks fine. Still about 2 volts peak to peak, frequency 230 hertz. Alright, let's go back to this scope. And go back to the Delta T. Tweak them a little bit. And I gotta hit these two to go to frequency mode. Let's see how good am I? 230 hertz or so. 230 hertz. So I think it works well enough with this basic testing. We'll test this more as I get the TV chassis that's sitting right next to it functioning, so I can hook this up to it. But my brief conclusion here so far is that the digital multimeter works fine and is actually pretty useful, and I could see myself using it. The scope works with some limitations. If I feed in, if I go too low with the time base, it starts getting crazy looking, aliasing, it starts getting ripply. But the reality is, why would I be trying to look at this waveform with this time base setting? Because it's not going to look right anyways. I'll show you how it would look on the Tektronix if I do that. It shouldn't get all bumpy like that, but it's also not going to be particularly useful if you're trying to analyze the waveform. And actually, you see a problem here now with analog scopes is you go to the low sweep rate. Well, you see this because of the persistence of vision and all that. But why would I be doing this? In other words, you pick an appropriate time base for the signal you're looking at, and then both these scopes are just fine. So it seems to do strange things, but I don't think that's going to affect it being useful, because you would look at this waveform at this time base setting and it looks fine and it's stable. So here's my summary for now. Would I recommend somebody buy this exact model right now? No. I've already seen higher end models for less. More capable models, dual channel, better bandwidth. But would I recommend this category of device? Depends what you're doing. If you have a small workbench, limited budget, you're not doing very demanding applications. By demanding, I mean complex modulated waveforms. I wouldn't be able to look at a 4.5 megahertz video signal on this. It's just going to be a mess. But for the hundreds of hertz, kilohertz, tens of kilohertz, I think it is just fine. If your eyesight's not so hot, get one with a bigger screen. And if you like the charm of having knobs to turn and not having to click and go through menus and toggle things and remember what buttons do that are multifunction, you're not going to enjoy working with this device. Thank goodness it has an auto mode, and intuitively the up-down do the voltage range and left-right do the time-base range. I just guessed at that, and that's what they do. But as far as adjusting like the trigger level, I don't even know if you can. And even if you can, you're going to have to push some buttons, navigate some menus. It's not going to be fun compared to an analog scope where you just grab knobs and switch modes and adjust your trigger level and all that. You know, you can get a used analog scope for the same price as one of these. But you may have to recap it, you may have to restore it, you may have to calibrate it. It's going to take up more space, it's going to consume more power, it's not going to be battery operated. So keep all that in mind. But hey, for now, if you get one cheap, it's a fun toy, play around with it. You can throw it in your pocket, you can do a field service call, or if you're out on a field day, you know, fully battery operated at a ham fest or something like that, sure, it's a fine thing to take along with you. That's it for now. We will be seeing this more as I get further into the project right next to it. Thanks for watching.